Okay. So now see here in the time domain analysis of a second order system. Actually, we are at the topic of error calculations. Now, so far what we are doing? So far what you are doing is you find the steady state error only for not this kind of systems. Now, so far what you are doing is you just find the steady state error only for this kind of systems. What is this system? What is the difference you observed here? This is the steady state error you are calculating so far. Now, what is the difference between this problem and this problem? This is the unity feedback systems. Unity feedback systems. And this is non-unity feedback systems. This is non-unity feedback systems. Now what you are doing, the steady state error is calculated only for unity feedback system. Whatever our formula and whatever we are doing, whatever our approach is valid so far only for unity feedback systems. Okay. So we cannot find actually the steady state error for non-unity feedback. We can find only the steady state error for unity feedback system. But what is the question is given here? Here the question is given, then find the steady state error for non-unity feedback. Sir, then how can we approach? So can I use directly the formula of steady state error, which is equal to limit s tends to 0 s into r of s by 1 plus g of s? No, don't use this one. This is the formula you are getting only for unity feedback systems, not for non-unity feedback systems. Okay. So now what should we do? If any non-unity feedback systems are given, see here, this is the non-unity feedback system. This non-unity feedback system, you first converted into unity feedback system. Understand or not? If any non-unity feedback h of s is not equal to 1 is given, then that non-unity feedback system, first it requires to convert it into unity feedback systems, and you can find a steady state error. So this is the forward path gain. I just represented non-unity feedback system. So equivalent open loop transfer function of a non-unity feedback system. Now open loop transfer function is nothing but forward path gain, but I want a forward path gain for unity feedback. So what should you do? First you simplify this. If you simplify this, this is the forward path gain, this is the feedback path gain. So this is the negative feedback, therefore up to this g by 1 plus gh, right? Like this you can get, actually this is you can get g by 1 plus gh. Now this is a negative feedback system, g by 1 plus gh. So now it will be converted to unity feedback. Okay. Now this non-unity feedback system is converted with unity feedback system by connecting the feedback. Therefore then what happened? Now it is a non-unity feedback system is connecting the unity feedback. So this is nothing but g by 1 plus gh. Now this is g by 1 plus gh divided by, this is forward path positive feedback, therefore 1 minus g by 1 plus g into h. So after simplification this you can get, which is g by 1 plus gh minus g. This is g by 1 plus gh minus g. This is g by 1 plus gh minus g, and this is the forward path and this is the unity feedback. Okay, understand now? This is the forward path and this is the unity feedback. But what is the steady state error is calculated for unity feedback. In such a situation, now this is your open loop transfer function. So what is the open loop transfer function for a non-unity feedback system? Is the open loop transfer function for non-unity feedback system is g by 1 plus gh into minus. Understand or not? No. Okay, so this is very important topic. If any non-unity feedback systems are given, that you first convert it into unity feedback, then you find the steady state error. So first you find the trans function. This is the closed loop control system trans function. Now you first find the closed loop control system trans function. This is step 1. Closed loop control system transfer function is g by 1 plus gh. How much? This is nothing but 100 by s into s plus 10 divided by 1 plus 100 by s into s plus 10 into h is 1 by s plus 5. So which is nothing but 100 by s into s plus 10 into s plus 5 plus 100. Is it right or not? Now this is the closed loop control system transfer function. Oh, sorry, I think this is. Okay, this is the closed loop control system trans function. But what is the non-unity feedback? Now this is a closed loop control system. Now you convert into non-unity feedback. Then now the non-unity feedback open loop control system trans function is non-unity feedback forward path gain is g by 1 plus gh minus g, which is nothing but the same thing, g 100 into s plus 5 by s into s plus 10 into s plus 5 plus 100 minus g. Minus g means minus 100 into s plus 5. Right? Now this is the non-unity feedback system. So this is the non-unity feedback system transfer function, which is nothing but 100 into s plus 5 by s square plus 10 plus 5, 15 into s plus 50. So this is nothing but s cube plus 15 s square plus 50s minus 100 into s minus 500. Plus 100. Therefore, finally, the non-unity feedback transfer function, which is equal to 100 into s plus 5 s cube plus 15 s square minus 50s minus 400. Okay, so note on this. So this is the system when converted into unity feedback to non-unity feedback, non-unity feedback to unity feedback. Now what is asking? Find steady state error to the unity feedback system for unit step input. So what is the type here? Is there any open loop poles at origin? No. Type is 0. Which input? Unit step input. Unit step input means what? R of t, which is equal to u of t, which is equal to 1, which is equal to t power 0. Type is 0, power is 0. Therefore, steady state error, which is equal to a by 1 plus k, which is equal to 1 divided by 1 plus k, which is equal to 1 divided by 1 plus k. Numerator constant by denominator constant. Numerator constant is 500 by denominator constant is minus 400. So which is equal to 1 divided by 1 minus 5 by 4, which is equal to minus 4 is the answer. Okay. Now this is the steady state error calculation. This is the steady state error analysis for steady state error for non-unity feedback. Okay, this is a separate topic. Okay, this is a separate topic, an important topic, because all we are doing blindly a unity feedback systems, but sometimes the question is in the non-unity feedback systems is given, so you can able to solve the question like this. Okay.